Well, today we are going to talk about our shaker technology and different applications, and we will review what are the challenges of vibration testing nowadays and how our company ETS Solutions is achieving high performance with our shaker technology and solutions. So first, let me introduce you the team. We are based in Colorado. Our manager is Graham Carmichael. He is industry legend for vibration testing. He has over 37 years of experience, and he really has led our company um, to achieve high performance on our shakers, and he has led the factory technically for the introduction of the induction ring shakers, which is something we will talk in this meeting. We also have Matt Millar for sales in the Northeast territory of the US, and myself in Mexico and USA Southeast. We also have a crew of technicians based in Rancho Cucamonga in California, where we have a service shop. And we also have another service shop in Detroit, Michigan, with 2 more technicians. And we have Sandra and Debra for administrative and logistics. So we are a nice team, always happy and always ready to help all of our customers. So before we go into the technical of this presentation, I want to talk a little bit about our ETS North America division accomplishments in the last decade. So we are now ISO certified for shaker manufacturing. We have installed over 400 systems in North America. Near to 100 of those 400 systems are of our high runner M748 shaker with 15,400 pounds force. And the reason is because that particular shaker is very cost effective for the pounds force that it delivers. We introduced the induction ring shakers. We introduced the IPA amplifier design, which we will also mention in this meeting. We have improved our quality significantly, and due to that and our technical experience and quick delivery, we are at pretty much all the major commercial labs in the US. To name a few, we are at NTS, Element, Intertech, Dynaqual, UL, and a few others. We have repair and rewind capabilities for all of our shakers and other shaker brands. We have a larger service shop that we recently acquired in California. This is an upgrade from our previous shop, which also was in Los Angeles, but now it's bigger, and now we have rewind capability. We expanded to Mexico in 2019, and we have installed over 25 shakers in these 4 years, plus about 40 chambers, thermal chambers. We are now 3 sales engineers and 8 service technicians. So our team is growing. Before we start into the technical, as I said, I want to just show you a quick overall of our company capabilities. We do maintenance, refurbish, repairs for every shaker brand. We are always ready to work on any system, either if it is water cooled or air cooled. We also do a lot of amplifier replacements. Here in the screen, you can see the before and after picture of competitive shaker using our new IPA amplifier technology, which is in the right picture, the blue and white, with the touch screen versus the original design, which was only knobs and buttons and LED screens. So let's get into the technical. So electrodynamic shakers, they are used in a variety of industries, starting from automotive, battery test, transportation, appliances, electronics. But there are challenges, and the challenges is that um, in the last decade or years, we see a tendency for higher force testing, high random tests for many hours, and we are talking about more than 40 GRMS, high accelerations for sine up to 220 Gs, high displacement up to 3-inch stroke, high shock applications up to 600 Gs and 3 millisecond. And this is really technology that didn't exist in a few decades ago. And even after it existed, there was only one company that was running these levels until we developed our shakers for these particular levels. And now we are in the competition, and we are putting systems out for space testing and for battery tests and other applications like this. So before we continue, I want to explain how a shaker works so that we understand what have we done to achieve the higher levels. So this is a cross-section sketch of a typical regular wire-wound armature shaker. And how this works is there are a couple of field coils which get a constant DC current, and they get magnetized. So when they get magnetized, the armature receives the sinusoidal or random signal from the amplifier, and it moves up and down because it is in the presence of the magnetic field. So this is the basic principle of function, and shakers like this have existed for several decades. And to this date, we still use this design because it's reliable for long stroke and for low frequency tests and low to medium forces. So our high runner actually is a regular wire wound shaker, and it performs well. Shakers are fun. We love them. You can with only 1.5 to 2 GRMS, you can test transportation. With 2 to 4 GRMS, you can test automotive sprung masses. With 10 to 20 GRMS, you can test engine components. You can even play music with the shakers. Here in the screen, you see a happy customer uh, paying honors to the national anthem that we are playing in the shaker while delivering this new unit. So we did this just for fun, but what I want to summarize in this slide is shakers are just fine. Regular shakers are just fine for up to 20 GRMS or so. If you push it a little hard, you can probably get 40 GRMS. But then if you push it harder, you get this. And we see this is our everyday job when we repair shakers that were pushed too hard. And why this is happening is because a shaker, they are not supposed to be run at 100%. Even if you run it at over 80% for so many hours, you will end up with a broken armature. And that's because the high currents and high heat effect on the armature coil. And these coils they use a wire that is epoxy glued to the upper casting of the armature. So it's a good design up to certain force and certain current levels, but this is limited to 200 G peak for shock duration, for short shock duration, or 50 maximum, 40 or 50 GRMS in random, but that's like kind of pushing it, and you get this. Why this is happening? Well, as I said, the regular shaker design, the coil is epoxy glued. This is not bolted. This is not welded. This is epoxy glued. So the epoxy, if you reach the maximum temperature, it will degrade and eventually will fatigue and break. So fortunately, you can always rewind it. And we offer this service, but a rewind service, depending on the model, it's going to be anywhere between $8,000 to $20,000 for the repair. And if you continue to push the shaker hard, you will break it again. So shakers are fun until you get this, and then you need to think yourself, okay, then what is the design that I need to run higher levels? Like, what if I need to test 80 GRMS and beyond? Because we see these levels in aerospace applications or defense applications. So for that test, you need a high performance, high reliability shaker with extreme acceleration capability. And really, at that point, your options in the world are very limited. I can tell you that there are only a couple of companies that can make these shakers, and fortunately, we are one of them. Being our main competitive advantage, the high quality, superior quality of the amplifier, and fast delivery. We can make these shakers in about 24 to 26 weeks, and we are cost effective. So let me introduce you our induction ring shakers. So how these shakers work in comparison with a regular wire wound shaker? Well, as you can see here in the sketch, the armature doesn't have any windings. It's a solid aluminum ring, and the output coils, we call them stators because they are static on the shaker frame, and the movement is by induction. So what is the advantage here? As we don't have any coils, the strength of the armature by design is way higher. An aluminum ring that is bolted. This is not epoxy glued, but bolted to the upper half of the armature casting. And the aluminum ring, you can accelerate it at super high accelerations and high forces because it can withstand higher temperatures, and we can run these shakers up to over 200 C with no problem, and we have a special cooling mechanism to keep the shaker cool. But this is the basic principle of function of an induction ring shaker. This is a better cross section, and you can see if you do the back-to-back comparison, in the left you have the stator coils. They don't move. They are not subjected to dynamic loads. They only see the output current and is cooled by water or by air, depending on the shaker size. And versus the right picture, which is a regular wire wound armature. So solid armature shaker can withstand much higher stress and temperatures than a wire wound just by design. Here you can see the failure mode of the epoxy glued armature coils, and the right side you can see the bolts that join the armature casting with the aluminum frame, with the aluminum ring. So bolting, just by logic, right? The bolting has superior strength than the epoxy glue. So in terms of performance, what you get? Well, you now don't have to worry about the dynamics of the coil because you don't have any coil. So the FN, the first natural frequency of these armatures is higher, and we have pushed the armature resonance to 2250 versus 2000 for the 22,000 pounds per shaker. You can run random tests up to 4,000 hertz. This armature has lower weight and therefore more usable force. And we also monitor the temperature. We have a thermocouple on the armature to monitor the temperature and be able to cool it properly or shoot it down for protection in case of overheat. So what levels can we achieve? And we have the test data to prove it. We can run up to 220 G in sinusoidal, 180 G RMS in random, 600 G peaks in shock, and we can run 230 inches per second in shock. That's 5.7 meter per second velocity. That's a huge accomplishment of this shaker. For those of you who are in need of high shock velocity, you will recognize that this is it's a high performance for velocity. So many companies are using our shakers for aerospace, and unfortunately we cannot mention all of them here, but I'm going to show you a list of a few applications that our customers are running. A rocket company is using our I-1045 shakers, 22,000 pounds force, to run 125 GRMS on the sleep table. That's something that you cannot achieve with any other shaker wire wound design. You absolutely need induction ring for those levels. You can break a regular wire wound shaker in a few minutes or even seconds if attempting to run these levels. Another rocket company, engine manufacturer, is using our I-1045 to run 150 GRMS. A satellite company has purchased or has reordered our shakers. They already had I-1045s and now reorder using the I-2060, which is the 44,000 pounds force to launch their new satellite network in space. And they actually features in their corporate videos. And we feel proud that we are being part of the space validation equipment. Rocket engine designs, a designer selects the M748. That's a regular wire wound, but they are testing lower levels for other parts, and this shaker is just fine for that application. NASA contractors are using our 1045s, and this is how the shaker looks like. You can see it looks aesthetically, it looks great, and the performance of this shaker is phenomenal. Here is a picture of a shaker, ETS solution induction ring shaker, featured in the corporate video of Astranis. I can mention this because they actually show them on LinkedIn, and that makes me really proud that they are showing our shaker. Astranis, as you may have heard, they are 3D printing their rockets, and they are using our shaker for validation, and yeah. Here is another picture of a special application that we have done, and this is for EV battery. You can see that this is not the typical shaker that you probably have seen. We can deliver this configuration with a regular wire wound shaker for low levels or induction ring. But this is a flexible configuration that we develop so that the EV battery companies can test the full package without the need of moving a massive sleep table. As you can see, this is a modular sleep table configuration with a main sleep table close to the shaker armature, and then a distribution of small 1x1 or 2x2 feet sleep tables with a linear bearing each to support the extremes of the EV battery package. So this helps so that you buy a relatively smaller shaker and still be able to move the whole mass of the battery car. This is something that we also have available for our customers. So going back to the induction ring shakers, we like to compare our induction ring shakers with F1 cars. And the reason is because the goal in F1 cars is to put as much power as you can in a lightweight chassis. And that's exactly what we do with our induction ring shakers. We have 5 models starting from 8,800 pounds force and up to 44,000 pounds force. And if you do the math of them, what is the ratio of the force divided by the armature weight, you get this factor that we call F1 factor. And I will show you a comparison of the 22,000 pounds force regular wire wound versus the induction ring so that you see how this F1 factor compares. Once again, the F1 factor is the force of the shaker divided by the armature mass. So if we do this back-to-back comparison with the 22,000 pounds for shakers from top to bottom and specifications, the induction ring can do 180 G RMS maximum. The wire wound can do 50. You can do 220 Gs in sine versus 100 of the wire wound. You can run the armature up to 260 C versus 100 C on the wire wound. And the F1 ratio is 218 versus 117. So the armature weight here is way less. It's like we're talking 25 to 30% less. And that's why for the same force capability of the shaker, you have more usable force because the armature is lighter. The armature resonance is 2250 versus 2000. This is great because for those companies that test below 2000 hertz, you will never excite the armature resonance, and that means that the stress on the armature due to deflections of the resonance will not be present. You can run up to 600 G in shock with the I-ring versus 200 G of the wire wound. So in summary, this is a big engine for a light chassis. That's a good comparison that we do of our induction ring shakers as an F1 force car. So I have pretty much covered the material, but I want to go quickly covering a few slides just to show you real test data that we have collected with our shakers. So as I already mentioned, we can do 220 Gs in sine, and here is the real test data. We have a single up to 2500 hertz. We have a single resonance approximately 2250. Shock performance, we can do up to 600 Gs, 3 milliseconds, or 300 G, 6 milliseconds. And you can see that at these levels, you need velocities of 230 inches per second, which is insane. That's a lot of velocity. Here are shocks with our I-1045 shaker, 450 Gs, 5 milliseconds. it runs perfectly. There's no way that you can run this with a regular wire wound shaker. 500G 3 millisecond, 600G 3 millisecond. This is the highest velocity we can achieve. That's 230 inches per second. We can do SRS, and we have tested our induction ring shakers for 2,000, 2,500 Gs in SRS. We can even verify 3,000 Gs for SRS with light payloads. Applications for this: SRS shocks, Raywell shock, fuse shock, separation shock, etc. And all of this is real test data. This is another test, impossible to achieve with a wire wound shaker. This is a 99 GRMS sign on random, 15-minute duration, and the amplifier shows an output current of 500 amps, and this amplifier can output up to 900 amps, so not even close to the limit. 125 GRMS random on a sleep table. I was trying to reproduce the video, but it looks like, oops, sorry. It looks like the video was not embedded there. Give me 1 second, please. Yeah, this is the 99 GRMS test run at our factory, sign on random. That's a lot of acceleration. This is 125 GRMS on a sleep table right there. The amplifier is running at 500 amps. So this is the evidence that we can run these levels without induction ring shakers. Here is another real test, 180 GRMS random for less than 1 minute. Run it at 700 amps, 760 amps. And this is our I-1045 shaker, 22,000 pounds force. So we have a very nice amplifier technology, which is unique in the market, and the reason is because instead of using hundreds of small FETs or IGBTs, we are using high power IGBTs transistor, 10 kVA each transistor. So we use a lot of, we use much less space for the same power, and we drive these transistors with a microcontroller, and therefore we are able to monitor the output, and we can balance the output of the different modules within 2%, and we can monitor for transients or peak current at 1 megasample per second. So if there's anything that can damage the amplifier, it will shoot down before breaking. And we released this amplifier 8 years ago, and we haven't had any single issues with this amplifier. We haven't broken any power modules yet. It's a super low noise floor. I personally ran this test myself. It's only 0.2 G flat sine from 10 hertz to 2000 hertz. And as you can see, it's clean all the way, and it's very low level. So the signal to noise ratio is great. We also use linear bearings for our suspension, and due to this, we can run these shakers really high with very low cross-axis response. As you can see here in the screen, there was a 110 G sinusoidal test, and the cross-axis response, which is the light blue and pink lines or traces here, are less than 10 Gs. So it's less than 10%. So in conclusion, our company, we offer a complete line of electrodynamic shakers, starting from low, medium to high forces, and really our range is from 440 pounds force and up to 151,000 pounds force. So we have a complete line of shakers for any application. But if you need high performance, we have a solution for you, and that's the induction ring shaker, which is designed for high reliability, high performance. And this system is an easy choice when compared with a wire wound shaker for in the performance specifications. We offer the complete solution. It's a high quality equipment, fast delivery, great price, and we are good with SRS, service reliability, and support. And that's all I have for you guys today. Thank you. Thank you for your time. We can do now some Q&A. If some of you have any questions, I'll be glad to answer. Thank you for being with me today. It's a pleasure for me to speak about our shaker capabilities, and hopefully we can help with your needs.